All right, so welcome to CSE 222. So how was your break?
Fantastic.
23.
Say
Yeah, fantastic. Good.
Could be better.
Yeah, could be longer for me.
Yeah.
I just started to get into the groove like last week, so, but that's okay. So if you're in this course, it means you survived CSE 222, or you have gone through the equivalent of that, and that's not an insignificant accomplishment. So congratulations on that. CSE 222 is, in my opinion, the hardest course of the entire sequence. It has seen attrition rates of up to 50% in the past. And this past quarter, everybody passed. So that's like awesome. So I know you worked really hard in 222, and I believe deeply that that's going to pay off really well, not just in this course, but down the road as well. Because students who have come back after university have told me that 222 was really the course that made the difference for them. So 223 is not without its share of work and challenges, but I think it's going to feel different from 222. 222 may have felt like a mad dash for survival and trying to get everything done. And 223 tends to be more, we know how to program, we know how to debug, we had experience with these things. Now let's use those tools and do some cool stuff, right? So we're going to play around with networking and pulling web pages off of websites and multi-processing, running multiple threads at the same time and having them coordinate with each other. Speech synthesis, reading mouse positions, doing some graphics, making GUIs, network communication, all kinds of things like that, right? And we're going to be using our skills in programming and using the environment of Java and the packages that come with that to do all of these things. And it really is kind of like the other side of some big hurdle, right? Where up to this point it was a lot about, well, learning how to program, right? Figuring out what algorithms are about, figuring out how to translate algorithms into code, how to debug when your code didn't successfully translate your algorithm, and tools, GDB and makefiles and tar and all of those kinds of things. And concept-wise, 222 was largely about recursion, okay, which is a big hurdle for most of us. And data structures, which in most cases was probably somewhat new and is really kind of the foundation for everything else that we do in computer science. So you've got this really good platform, the solid platform you're standing on now, and we get to use all that stuff to do some fun things, hopefully. So I think this is the most enjoyable course of the sequence. And like I say, it doesn't mean that it's totally easy and you never have to work and you're not going to spend any time writing code, right? It's definitely, you know, it's still a 200 level course, but I think you'll enjoy it in that way. So let me start off with the administrative stuff, the syllabus and the course policies and so on and so forth. And then we'll talk about Java. And tomorrow I want to spend class time going over the 222 final, because I made notes while I was grading it, and there's just a few things I want to just kind of comment on and sort of touch base on. So I'll do that tomorrow. But let's get through the logistics today, and let's get at least started on some Java code. We'll write a hello world in Java, just to prove that it can be done. All right, so let's look at details. So object-oriented programming, data structures in Java is what we're doing. So my name is Nick Macias, if you haven't been in here before. I'm Nick. So I have tons of office hours this quarter, some of them at 8, some of them at 9, some of them at 11. So they're scattered throughout. I have a total of 8 hours because I'm teaching Engineering 250, so I got 3 lab hours also. So you can find me either in my office or the collaboratorium. And the schedule is posted on the door, and the schedule is also online as usual. So hopefully at least some of those hours work for everybody. So there's an online text, Intro to Programming Using Java. This is a good text in my opinion. It's well written, it has lots of examples, lots of details. It's not just a big appendix that was ripped off from the web. This person actually wrote this book. And I find it pretty useful. Do not read it cover to cover. Do not print it out unless these are really the things you like doing, because it's big. It's like 1,000 pages or something crazy. And we're not going to do everything from there, and we may do some things that aren't in there, but it's a reference. But Java, has been around for a long time, and we're not going to be doing, Java 10 point something stuff. We're going to be doing Java that's pretty much been Java from more or less the beginning, at least back to Java 7. So tons of resources available online, but I also have a whole bookcase filled with Java books that are looking for homes. So if you want a physical copy of a Java book to mark up and highlight or whatever, stop by my office, and I've got one book in there that's mine. The others are free for whoever wants a Java book. Gothard found them a couple of years ago, and I gave them a home, but they're looking for a better home. So if you want a book, come by and see if I got one that you like. All right, course outcomes. Let's talk about the outcomes. So apply object-oriented design and programming concepts using the Java programming language. That's basically the punchline of the course, right? So we talked really briefly in 222 about object-oriented programming. Think structures plus other stuff, structures plus code, right? So we're going to spend a lot of time learning about objects and object-oriented design, and Java is going to be the language we primarily use. We may touch on a little C++ later on, but basically it's a Java programming course. And Java is a lot like C. You can write C in Java, okay, but I don't recommend it, because then you're just writing C, but you're calling it Java. But Java is C plus objects, basically. So we're going to be working on that object part a lot. So various programs we'll be writing. We'll be dealing with encapsulation, abstract data types, information hiding, all of these concepts related to object-oriented design, some of which we touched on a little bit in 222. Abstract data types, right? User view, view under the hood, that kind of stuff. We'll be talking about data structures, so trees, heaps, hashes, lists, things like that. But a lot of these things are available for us already in Java. Now some of these we'll write ourselves, but we'll also look at predefined packages that implement things like linked lists, for example, or hashes, and we'll get some practice in using those. We'll continue to talk about space-time complexity, so order of complexity, big O notation, as we're going through looking at algorithms for sorts or searches or graph manipulation and so on. We'll keep coming back and looking at these complexity questions. Memory management, concurrency, synchronization, and related issues, right? We're definitely going to spend some time talking about multi-threaded behavior. So we have two or more processes running simultaneously. And this is doable in C, but it's kind of weird to try to do in C. In Java, it's completely painless to set this up. But there are so many potential gotchas once you have more than one thread executing code, especially if they're sharing information. You start getting into questions of synchronization. For example, process 1 is waiting for process 2 to do something, but process 2 is waiting for process 1 to do something, and you've got deadlock. They're both waiting for each other, and your system isn't making any progress. So we'll spend some time looking at that and looking at ways to detect and deal with all of these issues. And the last outcome is doing some teamwork. So your 5th programming assignment will be a group project, and you'll put yourselves in groups and get some more practice with that. So those are the outcomes. Grading. So no ODPs, no labs. So simplified grading rubric. So programming assignments, 30%. I'll have some online quizzes on Canvas, which will start off being 10% of your grade. I'm not planning to take attendance for now, but if enrollment drops off, I'm going to start taking roll. And in that case, attendance will be 5% of the grade, quizzes will be 5%. So tell your friends to come to class. And then midterm and final exam, 20% and 30%. Service learning project, 10%.
Are the one-day projects just irrelevant in this course?
So I debated doing this. So last year I did some ODPs for 223. It just doesn't feel like that kind of subject to me. The ODPs were really about, here's some incremental concept, and I want to make sure that people understand it. And people were coming from such a different background. Some people had taken 121 2 years earlier and gotten a C and forgotten everything in there. And some people had been programming, the whole summer and throughout the whole sequence. And so I was trying to sort of like give everybody a way to sort of assess themselves and make sure they were at, where I wanted them to be. And 223 Java doesn't feel like that to me. I've had some people ask if I could offer some programming problems to work on and such, and I'm going to do that. So I'll put some stuff out there, but I'm not going to grade them and assess them. But if you want things to work on to give you extra practice, right, I'll offer those. And then labs, I did labs in this course last year, and I think they were fun. But for the hands-on component this year, I think we're just going to do some more stuff at the board. So we'll work with a concept, we'll learn some algorithm or some concept, and then we'll do some activities in class where you'll either go to the board or work at your desk in groups, and we'll use that for the hands-on stuff. So a simplified amount of things, and the quizzes, like I say, they'll be on Canvas. I have to put them up, but they'll be basically short answer things similar to the kind of short answer stuff you see on exams sometimes. So probably 5 or 10 questions per quiz. All right, and final grade is just numeric average, and you can find the letter grades on the ECS page. Academic honesty and plagiarism. So I'm not worried about this in this course. Okay, I'm not worried about this with any of the students in this section or the other section. As far as academic dishonesty, as far as I don't feel like doing my work, here's $10, give me your code, and I'll change it. Okay, I'm not worried about that. There's always this underlying concern about thinking that you're writing your program, and in fact, you're getting more help from some other source than you think you are. For example, I'm having trouble getting this thing to compile. Can you see anything wrong with this? Oh yeah, you forgot the semicolon there. Okay, that's fine. That's harmless. That's probably what I would do if you came to me and said this isn't compiling. Is there a problem here, right? But I don't understand how to do such and such in this assignment. Can I see what you did? Here's the code, and you study it, and you think about it, and now you have an algorithm in your head, and now you go ahead and you write your code. Chances are that if you saw that similar question on an exam, you might have trouble doing it, unless you could go back and look at an example, because you didn't figure it out yourself, and it's that process of figuring it out. So there's always this line that you have to sort of be aware of working with someone is fine, but make sure that you're actually coming up with the solutions yourselves. And if you're looking for help and you're not sure how much help you should get, come to me, right? And I'll try my best to guide you in the right direction without giving away the answer, because you want to figure out the answer yourself ultimately. So that's the main concern that I have up here. But obviously don't give someone money for a copy of their code and stuff like that. People do this, okay? You can go online, you can find services for a few bucks, you can send them your assignment, they'll send you code. And it's very hard to detect, right? Because if somebody's actually writing you a program for an assignment, it's not gonna set off any flags, right? But ultimately, either you get caught or you get into a situation where that's not an option. And the further down the road you are when you get in that situation, the worse it is, because now you're in your first job and you've been asked to write a program and you can't do it, and so better to struggle now. All right, so late assignments. Programming assignments, again, I will let them turn in 24 hours late for a 25% penalty. Just in case something happens and you miss the deadline, which is usually 8 a.m. Right, so I overslept, I had my watch on, Greenwich Mean Time instead of Pacific or whatever. Just so you have an option other than getting a 0. Right, turn it in as soon as you can after the deadline, within a day, and you start off with a 75. But don't think of it as like, oh, I'm just going to take an extra day to do this, because 25 points is hefty. Don't miss your exams, don't abuse the equipment. So those are straightforward. Support services, so I've talked about this before, let me just re-emphasize. If you have a situation where you feel some kind of accommodation would help you in this course, don't hesitate to talk to me about it, or talk to the DSS office, or talk to somebody about it, right? And this applies to every course that you take here. There's a goal of equity, right, in student experience. So everybody can come in and sit wherever they want. That's equitable, right? That's equal. So you have difficulty seeing the board from the back of the class, but you have to come in from across campus, and every time you get here, the only seats left are in the back of the class. That's not equitable, right? If that's an issue, we can figure out what to do about that. We can have a reserved seat in the front, for example. So there's all kinds of options here for accommodation: extended testing time, testing in a low distraction environment, having a note taker, and so on and so forth. So let me know if you have any concerns or questions about that. The non-discrimination policy, I always read this one out loud, so this will be my one reading from the slide for the quarter for this course. So here's Clark's non-discrimination policy, and this is across the board, not just this course. Clark College affirms a commitment to freedom from discrimination for all members of the college community. The college expressly prohibits discrimination against any person on the basis of race, color, national origin, disabled veteran status, sex, sexual orientation, age, gender identity, creed, gender expression, Vietnam-era veteran status, religion, marital status, and presence of physical, sensory, or mental disability. The responsibility for and the protection of this commitment extends to students, faculty, administration, staff contractors, and those who develop or participate in college programs. It encompasses every aspect of employment and every student and community activity. So again, if there's some concern, if there's something that is potentially interfering with your ability to, in this case, focus on CSE 223, but whatever course, even if you're not sure that there's an actual issue here, right, you can always come and talk to me or talk to somebody else, and we can explore it. And if necessary, I can put you in touch with, Title IX representative or whoever is appropriate for the situation. And it's something that the college takes extremely seriously. So we want you to concentrate on learning and being successful in your courses and whatever your goals are here. So any questions about any of that? All right, so you can read the Student Code of Conduct, Code of Student Conduct, and so on. And I'm going to talk about course policies in a moment. All right, so that's the general syllabus, and that's on Canvas. The next thing on Canvas is the additional course policies, and this is the stuff specific to spring 2019 CSE 223. So my office is the other side of the collaboratorium, 2 doors down. Collaboratorium is the big middle space. 2 doors after that is my office. Office hours are available online. It should be HTTPS. I have to fix that. And it's also posted on my door. But I have plentiful hours. So you don't need to write this down, but office hours are basically today at 11, Tuesday from 9 to 10 and 11 to 12, Wednesday from 8 to 10, Thursday 9 to 10 and 11 to 12, and Friday from 9 to 10. So there's some 8 o'clock, 9 o'clock, and 11 o'clock options. This course assumes proficiency in programming. Everybody knows what an if statement is? Good? Okay, cool. Generally no extra credit. There may be some extra credit opportunities, but please don't count on it. Don't skip your second programming assignment because you're planning to volunteer for MESA later and get the points, because I don't know what opportunities will come up, if any. So please come to class. I don't have to tell you this because you're here right now, but if you're home watching the video and you didn't already contact me with some explanation, please come to class, okay? For a few reasons. One, we're going to be doing some hands-on stuff in class. Two, I'd like you to participate in class as much as possible instead of just listening to me drone on for 50 minutes, right? If you can ask questions, if you can respond to queries from me and so on, you're going to get more out of this, right? This is the same thing we've talked about every quarter. But watching the videos at home is not going to take the place of coming in. And so this is part of why I might start taking attendance if enrollment drops. Because it's important, and I see this consistently on the programming assignments and on the exams, where, you know, in class we'll very clearly say you've got to do this or you're going to lose points, and then people don't do it. And they say, well, I didn't know I had to do that. Well, we said it in class, and the people who were in class knew it. Or we'll go through, you know, something on the board, maybe for a day or two, balancing trees or something like that, and I'll say you're going to see this on the exam, and then in the exam people leave that blank because they have no idea how to do it because they didn't come to class. So I don't have to tell you this because you're here, but keep coming to class, okay? It'll be good. All right, so let's talk about emails. So part of what I want to do in this course is make sure that you're in as good shape as possible for moving on to a university, a work position, whatever else is coming on down the road. So I'm going to start backing off from things like responding to emails about, you know, I'm getting a compile error, can you tell me what's wrong? Use the discussion area on Canvas. Okay, this is a much more common model for businesses, for WSU, for other schools. There'll be collaborative tools that you can use online to brainstorm with other people and such. If you send me emails asking about things like this, I'm probably not going to reply. I'll read them, but I probably won't reply until I see it posted in the discussion area. And then I might jump in. Again, if it's something very specific, I can't make it to class tomorrow, but I really wanted to talk to you about such and such. Is there another time we can meet, right? Obviously send me an email. But I don't understand what the program's supposed to do, or I'm having trouble figuring out how to read input from a file in Java or things like that. Go to the discussion area and start a talk. And let's get this as interactive as possible. Exams, closed book, 4 pages, double-sided as usual. Programming assignments, write the code yourself. We already talked about that. Programming assignments must be submitted correctly. So 224, 222, I tended to give you a break. If you submitted your tar file and I tried to untar it and it was corrupt, I'd send you an email. And I said, you know, send me a new tar file, and as long as the dates were before the deadline, I went ahead and graded it on time. I'm not going to do that this time, okay? If I try to compile your program and it doesn't compile because you added some comments at the last minute and one of your comments had a slash instead of 2 slashes, right? I would go ahead and I'd fix the comment and I'd compile your program. I'm not going to do that this time, okay? So we're moving into a mindset of you know, more like a 4-year university where it might be like, here's my assignment, and it gets graded exactly the way that you turned it in. So I'm going to give you very specific guidance, particularly on PA1, on how I want it submitted, how I want it structured, and so on and so forth. Okay, and we're going to try to get really good at sort of following a specification like that. So we'll talk about that with PA1 later on. Programming style counts. So you should be pretty well developing a program style at this point, which means you don't have everything left justified in column 1. You're doing some kind of indenting, you're doing some kind of reasonable naming of your variables, and you're doing comments, okay? And I need to see those, and they're definitely going to cost you points this time if there's no comments and everything is starting in column 1 and so on and so forth. So so come and talk to me if you want to talk about programming style. That's pretty much it for course specific stuff. So any questions on any of that? All right.
And all of this can be found on our syllabus?
Yeah, so let me take you to Canvas. So there's the syllabus, there's the additional course policies we just looked at, a link for code samples, a link to Oracle's Java documentation, which is probably your best source for just a reference for the stuff we're doing, a link to the lecture videos, programming assignment 1, which is already posted, midterm and final, and SLP. And we still have to talk about SLP. Let's go ahead and talk about SLP now. So theoretically, you've been working on your service learning project for 2 quarters now, at least. And the first quarter was you know, exploring an idea and sort of working out the details and finding the right level to pursue and so on. And the second quarter was theoretically, you know, developing an initial prototype or doing whatever you needed to do to sort of like verify the idea and kind of get yourself ready for quarter 3, which is where you're actually trying to make the forward progress and come up with something like a prototype, okay, or a mock-up or some kind of semi-finished product for the end of the SLP. So there's the presentations the last Tuesday of the quarter from 3 to 5 as usual. But your final upload for this quarter is not the one-page poster. It's actually a full-on technical report. Okay, it's a report that summarizes your whole project, and basically it's a report so that somebody else with your similar skill level but who knows nothing about your project could take this report and reproduce your work. So it's got to have, you know, a description of the project, why you're doing this, what it does, how it works, circuit diagrams, code, flow charts, everything that you need to know about it. Okay, it's the thing that you would, you know, hand the venture capitalist who gave you $1 million to do this project back in September, and you say, here you go, right? And it better not be a one-pager, because they're going to be like, yeah, give me my $1 million back. So there's an entry here for the final upload, and I have a link to a template of the basic sections that you want in your report, but you don't just fill in a few sentences in between each of these things and turn that in, okay? This is just an outline. So you upload a PDF. Each member of the team has to submit their own copy of the report. It can be one shared report among all the people, but I want everybody to actually upload their own report just to make it easier to grade. And if you're taking one of these odds classes, that's probably not the case here for 223. But if you're doing an upload for another course, you still have to do it for here. So let me show you the template. All right, so this is all that I just said, basically. So here's the 7 sections that I want at a minimum. Okay. So description of title page, right, with your name and so on and so forth. Description of objectives, right? So what's the problem that you're solving? What extent are you solving this to? What's the scope of it? alternative solutions, so that's your competitive analysis. So what are the other solutions to this problem right now? And to some degree, you know, how is my solution better? How is it worse? How does it compare, contrast, and so on and so forth? So a competitive analysis. Solution specification, this is the biggest part probably of the whole report. This is everything that somebody needs to be able to reproduce your work. So system diagram, block diagram, code, schematics. If you have a lot of code, you can post a link to Git and put your code up there if you prefer. But basically enough so that somebody could, you know, if you're building a face recognition doorbell that sounds a different chime based on who's ringing the bell, right? You got to see the circuit diagram, the code, and all of that stuff in there. Verification, test plan, and results, verifying that you've actually done whatever it was that you wanted to do. So you're trying to build something that does X, right? And you've built your thing. Does it do X, right? So how do you validate that? Again, think of the venture capitalist. You're giving them this report to satisfy the conditions under which they gave you $1 million to do this project. They want to see, you know, so I had 5 friends come over and they each rang the doorbell and it gave a different tone for each of them. And then someone held up their cat and rang the doorbell and it made a different sound and whatever, right? So have a test plan, do your tests, write up the results. And then if you were to continue this in the future, what would you do? What would be the next steps? Doesn't mean you're going to do it, because if you're graduating, you may never look at this project again. But what would be the enhancements in the future? And then lessons learned, right? So what's the take-home message from all of this? You've spent 3 quarters working on this project, and it's supposed to be a learning experience. Did it end up being a learning experience? And if so, what did you learn? And if not, why not? Should I have picked a harder project? Did it turn out I wasn't interested in this, right? So talk about that. And then the last thing is the license terms. So if you want this to be totally open source and available for the world, you can go verbatim and just put these license terms in. But if you want it to be more restrictive, if you're going to actually take this and market it somewhere and you don't want people to have access to this, you can put in a restrictive license and we will keep it confidential. We won't put this on the website, for example. Does that make sense? Okay, so SLP presentation is that last Tuesday, June 11th, 3 p.m. And if you cannot make it, if you have a conflict, you have to send me an email before 5 o'clock this Friday and tell me that you want an exception to attending. Otherwise, you're expected to attend. So same as last quarter, basically. All right, let's talk about Java. So Java looks a lot like C. When I first learned Java, I basically was writing C code, but I was compiling it with the Java compiler command, and I was running it with the Java execute command, but it was basically C code. And that's kind of a shame, because Java is this big, very rich and powerful environment. And if you just write C code, you're using this tiny little piece of it, right? And you may as well just be writing in C. So to really, really make good use of Java, we need to get into a mindset of object-oriented design. And that's going to be a bulk of what we do in the beginning of this course, is play around with objects, learn what objects are, what classes are, and so on. But that's going to take a little while. And PA1 will basically be not a terribly exciting project, but it'll be all about creating a class and working with objects. So it'll be kind of the mechanics of that. But let's take a step back and look at Java more abstractly. And in this course, we're mostly going to be using IDEs, integrated development environments. So an environment where, you know, you type in an editor and it knows you're writing Java code, so it'll do color coding and it'll tell you where you've got syntax errors. And when you want to compile, you just hit a button and it compiles it. And when you want to run it, you hit another button, and it's all sort of tied in together, right? And we're going to use 3 IDEs. The main one we're going to use is IntelliJ. And it's a free download. There's a commercial version and there's a free version. Use the free version if you're just starting off with IntelliJ, because it works fine for what we're going to do. So we're going to use IntelliJ mainly, but I'm also going to talk a little bit about NetBeans, just because it's another example of an IDE, and it's a very sort of small, fast, efficient way to do some of this stuff in an integrated environment. I'm also going to talk about Eclipse, because Eclipse is still used fairly often. It's still used at WSU as far as I know. And we used to use Eclipse exclusively in 223 up through last year. It's gotten harder and harder to keep using Eclipse. There's more and more issues that come up. There's more issues with using Eclipse on a Mac. There's more issues with Eclipse and newer versions of Java. And it's just gotten to be this like ongoing battle. So we're switching to IntelliJ this year, which is what more and more people are using, it seems. And it also sets you up for doing Android development, which is kind of nice. But for programming assignment 1, we're not going to use an IDE. We're going to work on the command line, because you know I love working on the command line. So we'll go on the Linux server. And we can run Java directly from the command line here. Did you get an announcement about student accounts from me? Okay. Well, I had it sitting in there before I published the course, and then I published it, but I don't know if it automatically sends announcements once I publish the course, so I'm not sure. But, okay, well, tell me if you've seen this. For those who are registered by Thursday, you should have an account.
I didn't look at my account yet.
Okay. Well, anyway, so if you were in 222, you should have an account in here. If you were not in 222, but you were already registered as of Thursday, then you have an account, and there's your username and there's your password. And if you weren't registered and you weren't in 222, you probably don't have an account. Send me an email, and we'll set you up. But anyway, go to your announcements. There's an announcement up there. All right, so we're going to work on the command line, which means we're going to write code using VI or whatever your favorite editor is. I'm not going to insist on VI this quarter. You're going to write your code with an editor, and then you're going to compile it, and then you're going to execute it. Okay? And Java cares about file name extensions. So whatever your program is, it's got to be called something.java. And when you compile it, you're going to say javac and then the name of your program. And that's what we used to do with GCC. Right? This creates something like an executable program, but the thing it creates is actually program.class. Not exactly, but basically. And this is effectively an executable program. And the way you execute it is you say Java, and then just the name without the extension, Java program in this case. And that'll run it. So it's similar to C. We compile and then we execute. But there's one key difference, which is in a C program, when we compile it, it creates a file of ones and zeros that actually get loaded into the computer's memory, and the CPU looks at and starts executing. With Java, that's not the case. The ones and zeros that we get by compiling this program are not something that my laptop understands. If I take those ones and zeros and dump it into memory and then point the program counter there, my computer is going to crash. So with Java, we have this thing, which is a virtual machine, the Java virtual machine, which is sitting on top of the CPU. And our executable of sorts, our class file, gets interpreted by the JVM. So Java is not a compiled language per se, it's an interpreted language. It gets compiled from the human readable form into this class file, which we call bytecode. And then the bytecode is interpreted by the JVM. Okay, there's a downside to this, which is performance. Because if we take ones and zeros, we dump them into memory, and we point the program counter at those instructions, our program's running as fast as the hardware will support. In this case, we've got a program running, written in C, by the way, called the Java Virtual Machine. It's running, and it's reading the contents of this class file, and it's saying, oh, 1101011101. Oh, that means I should increment this variable called I. And so it figures out where it's storing the value of I, and it adds 1 to it and stores that back. And then it goes and it looks at the next set of instructions in this file, and so on. So there's this layer of go-between between the actual hardware and the execution of our bytecode. And that's an efficiency penalty, but it's not too bad anymore. It used to be pretty bad, but things are so fast now, and JVMs have gotten really sophisticated, so it's not a big performance hit. What's the advantage of having a JVM in there? What's the advantage of this middle layer?
Portability.
Portability, that's the advantage. Because if I say GCC and I compile a C program on my laptop, which is an x86 machine, and I get an a.out, which is executable, I can say a.out and it runs, right? If I take that a.out and I put it on a Raspberry Pi and I say a.out, it won't execute. Because Raspberry Pi is using an ARM processor, different ones and zeros. And if I take it over and I put it on a VAX machine and I say a.out, it's not going to execute there either, because that's a different CPU. With the JVM in between, the JVM always understands this bytecode. All I need is a JVM that runs on my laptop, another JVM that runs on a Raspberry Pi, another JVM that runs on this other machine, and I can take the same bytecode and execute it on all of those platforms. So you got a smartwatch running Android, right? There's a little JVM inside there, and I can dump my code on there and execute it, and I don't have to recompile. So that's kind of cool. So it's great for portability. All right, so let's write some Java code. We got 6 minutes. So let's make a hello world. Okay, so my file is going to be called hello.java. And since my file name is hello.java, the thing that I defined in here has got to be the same name, hello. If I call it goodbye, the compiler will complain. And we'll spend a lot of time talking about what class hello means. Okay, but just think of it as a structure statement for now. I'm defining this thing called hello, and inside these curly brackets, I'm going to put in a description of what this thing called hello is. And my class hello is only going to have one thing. It's going to have a main program. And our main program is like an incantation when you're summoning a genie or something. It's got to have a very peculiar format. Okay, and if you put in a different format, it will compile, but it won't be a main program. So here's the format: public static void main. And if you change any of that and you try to run it, it'll say, I don't know what you're trying to do. Try typing public static void main. Okay, so it knows what you meant, but it's going to make you say it. So we'll spend a few weeks getting to where we understand what public static and void mean. But main is the name of our program, and it's a magic name. It's the name of the main program. And like functions in C, we have parentheses after it with a list of arguments. So we're not going to do integer argc, char star star argv, and all of that nonsense. So for one thing, strings are a built-in type in Java. So we don't have to do character arrays anymore. We can actually say string space variable, and now it's a string. And it's got things like lengths and ways to combine them and do all sorts of stuff. So string is a variable type. And our argument to main has to be an array of strings. And we specify an array of strings by just saying string bracket bracket. And then we can call our variable whatever we want, and typically it's called args for arguments, but it could be anything. So there's the first line of my main program. And I'm just going to print out hello world. So our print statement is a little peculiar. So system.out.println, parentheses, and then in double quotes we put in the thing that we want to print. And that's our whole main program. And println means put a new line at the end, so we don't have to put in the \n like we do in C. Okay, so there's my hello.java. I'm going to compile it with javac hello.java. And that creates a hello.class. That's the compiled bytecode. And if we were to look at that class file, it's mostly gibberish to us, right? It's got some ASCII stuff. There's hello world right here in the middle of all of this. So that's presumably the hello world that I typed. And it's got some stuff that's meaningful to, you know, paths and stuff. But then there's just a lot of like ones and zeros, bytecode. So if we want to execute that, we just say Java and then the name of the class hello, and it executes the code. So that's your basic hello world, right? Sort of a minimum executable program in Java, executable main method. And we're going to spend a lot of time learning about what each of these things mean, because each of them is very particular. The public static void, the string bracket, system out, and so on. But at some level, it's that simple, right? You edit your file, you compile it with javac, you execute it with Java. And this is very simplified to say that it compiles this into that, because it's more complex than that. But that's good enough for first purposes. All right, so tomorrow let's start actually digging around with Java for real, and we'll start getting into the language, and we'll start looking at objects, and we'll be working up to a discussion of PA1 sometime in the next few days. All right, so I will see you tomorrow.